All right, picking up on number 13, where we left off yesterday. So, on number 13, if AB has endpoints A, we had 2, 13, and midpoint is 10, negative 1, then give the coordinates of B. So, on this one, we're given one endpoint and we're given the midpoint. This is where we used what I refer to as the no-man method. So, we can do an endpoint, the midpoint, and another endpoint. So it looks like a snowman. Endpoint that we know is at 213. The midpoint that we know is at 10, negative 1. The way you figure out what the other endpoint is you have to find how you got from here to here. So from there to there, we actually had to subtract 14, so minus 14. So then we subtract 14 more to get to our next value, which would be negative 15. On the other side, we actually added 8, so plus 8. So add 8 more, plus 8. That gives us 18. So our value here is 18, negative 15. On number 14, what is the distance between these 2 points? So you have to know your distance formula. Distance formula is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So plug in. We have distance equals the square root of 5 and negative 9. We can plug in for the x values. Plus, we got the negative 4 and the 2. Minus, not comma. So now that is the square root of negative 9 minus negative 5. That actually becomes plus 5. So that's just negative 4 now. This negative 4 minus 2, that's 6. So, negative 4 squared is positive 16. 6 squared is 36. 16 plus 36, that's 52. So we have the square root of 52. Which we could either write as a simplified radical or as a decimal. So, acceptable answers, square root of 52. If we broke this up, 52 could be 4 and 13. So square root of 4 is 2. 13 would stay under. Or as a decimal, square root of 52 7.21, rounded to the hundredths place. So those are acceptable answers. On 15, given ABC is isosceles with these two sides equal, if measure of angle A is 30 degrees, find the measure of angle B. So, based on how this is set up, B, since it's on both legs, must be the vertex. So I'm going to draw my diagram here to help me out. So I have A, B, C. Those two are equal. A is 30, therefore C is also 30. Both of those are 30, and then subtract those two from 180, so minus 60. This is with 120. Diagram's not drawn to scale, it doesn't need to be. We got our answer. On 16, given triangle RST is isosceles with RS equal to ST, so now this time S is in both legs, therefore S must be our vertex. It says R is 40. Find S. So this is essentially the same type of question. That would also be 40. Subtract those two from 180. Because all angles in a triangle add up to 180. So that's 100 degrees for S. Number 17. Given same triangle as isosceles, they gave us different parts though. T is now on both legs, so T is the vertex. Angle R is 40. Find S. Well, those two are congruent, so it's just 40. No actual work needs to be done. Number 18. We have a diagram for 18 and 19. So 18 was, there was a lot of people that got that one right, but 19, a lot of people got it wrong. So on 18, let's see. In the diagram above, if angle 1 is that and angle 2 is that, what is the measure of angle 2? Well, 1 and 2, they are not congruent here. Remember, when we have parallel lines, which they should have told us on there that these are parallel. We probably shouldn't assume that. But that's the only way we can answer these questions is if those are parallel lines. So if these are parallel lines, then all the acute angles here should be congruent. All the obtuse angles should be congruent. Any combination of one obtuse and one acute from this should be supplementary. So 1 and 2, one was obtuse, one was acute. These must be supplementary. They must add up to 180. So add these two equations together. 5x and 3x gives us 8x. 20 and 16 gives us 36. So again, adding up, they give us 180. We'd subtract the 36, so that'd be 144. And then 144 divided by 8 gives us 18. Which is A. 19, very similar question. This time they want us to find. Wait. I did not go far enough with the last problem. That is not the final answer. Again, you gotta make sure you read the question. I think that's what happened on 19. I think a lot of people didn't read the question on 19. On this one, all right, we had 18, but then we had to plug it back in. We had to find angle 2 as well. So plug it in for angle 2. So we're plugging into this equation. 3 times 18 plus 16. 3 times 18 is 54. Plus 16 is 70. So sorry, D is the correct answer, not A. 19, almost the exact same problem, except we're solving for angle 1. They also changed the values on it, so it's not the exact same numbers. Now, there's only slight differences there, so be careful. So add these two together. Again, they still have to be supplementary. So that's still going to give us 8x. This part, though, is going to give us negative 12. Bring the 12 over by adding it. They give you 192. And then 192 divided by 8 is 24 for x. This time they want angle 1, so we have to plug into this equation. 5 times 24 minus 20. 5 times 24 is 120. Minus 20 is 100. That one is not multiple choice. So that also made it a little challenging. Remember, all the questions will be multiple choice on the test. But again, things like that x value would be probably a choice. Things like if you plugged it in for angle 2, that would also be a choice. So just because the exam is going to be all multiple choice doesn't mean it's going to be easier. You got to still make sure you're answering the question that's being given. All right, number 20. All of these were pretty low as far as correct answers go. So let's take a look at each of these. angle 1 and angle 11 are corresponding angles. True or false? So angle 1, angle 11. So angle 1 corresponds to 3. Angle 1 corresponds to 9. 9 corresponds to 11, and 3 corresponds to 11. So this one is a little bit challenging, and I don't think you'd see this one on your test because you could argue that this is actually a true answer, but it is indeed false because 1 is corresponding to 9, 1 corresponds to 3, and then 3 corresponds to 11, and 9 corresponds to 11. So what we can say about 1 and 11 is that they are both going to be congruent to one another. Are they technically corresponding? Not exactly. All right. B. For 7. Again, in order for those to be congruent, these would have to be parallel lines, and those would have to be parallel lines. All right. On 7 and 5, these are angles in the same position. Those are definitely corresponding. That is true. On C, since no lines have been said to be parallel, then there are no corresponding angles in this picture. That is false. Corresponding does not depend on parallel lines. The corresponding angle theorem, which says that the corresponding angles are congruent, depends on parallel lines. All you need to say that you have corresponding angles is 2 lines that are being cut by a transversal, and the angles that are in the same position would be corresponding. Angles 5 and 7 are alternate interior angles. 5 and 10 are alternate interior angles. 5 and 10, they are inside these 2 lines of A and B, opposite sides of Q, so that is a true statement. They are alternate interior. For E, 14 and 11. 14 and 11, those would also be alternate interior angles because they're alternate, they're on opposite sides of B, but they're inside P and Q. So that is also true. All right. So, again, just to recap, false, true, true. The one that's probably the most confusing is A, because if these lines are parallel, those two would be congruent, and yes, they're in the same position, but by the definition of corresponding, the definition says angles in the same position when 2 lines are cut by a transversal. 1 and 11 are not on the same line or the same transversal, so it does not work. But they would be congruent if they were parallel lines. All right, 21. Find the value of x and y in the diagram below if the lines P and Q are parallel. So, not saying these are parallel, so we can find some measurements. So, we can't combine x and y in the same equation because you can't have 2 variables in the same equation. So we're going to have to use the 2 x values in the same equation, the 2 y values in the same equation. For the x's, we have 4x and 3x plus 20. So these two are in the same position. They have to be equal. 4x equals 3x plus 20. Bring the 3x over, you get x equals 20. For y, these two would have to be supplementary with one another. So add them together, you get 8y minus 60 equals 180. Add the 60, you get 240. Divide by 8, and you get 30. And I just want to double check and make sure that those are the only correct answers and that he didn't mess up on this question. So I'm going to plug those values in and see what we get. If I plug into these two, those two should end up being equal or congruent. So let's just see. 3 times 20 plus 20 is 80. 3 times 30 minus 10 is also 80. So that's one way that we could double check that answer, is we could use the property of vertical angles must be congruent. In this case, both of those angles would end up being 80. So there is more than one correct way to solve that problem as well. All right, on 22. If measure of angle AEB is this, and measure of angle DEC is that, what is the value of x? Well, AEB is this angle here. DEC is this angle here. Those two are vertical angles. They are congruent. So set them equal and solve. Now, there's more than one way you can go about solving this. So do it whichever way is easiest for you. I personally would want to get rid of the 1/2. So I'd multiply everything by 2 to get rid of the 1/2. Multiplying by the denominator gets rid of that fraction. So if I multiply everything by 2, I then get 4x plus 64 equals x plus 130. Now I can combine like terms. And let me show that last step too. So again, I multiplied everything by 2. All right. So now, combine like terms. I'm going to go ahead and bring this x over to the other side. And bring the 64 the opposite way by subtracting. So we get 3x equals, let's see, 130 minus 64 gives us 66. Divide by 3, and we get 22. Now, they only want the value of x, so that's our final answer. On 23. CAR is isosceles with CA and RA equal. So CA and RA are equal. If measure of angle CRD, so this exterior angle is 105, then fill in the angle measures below. So there's a couple different ways we can do this. 105 in this one, these are supplementary. They form a linear pair. So this should be 75. I subtracted that from 180 to get 75. These two angles here have to be congruent because this is isosceles, so the base angles of an isosceles triangle are congruent. So that 2 is 75. To get this angle, I could either subtract both of these from 180, or the two remote interior angles have to add up to the exterior angle. So I could just say 105 minus 75 equals this angle. So 105 minus 75 is going to be 30. Then we have this angle would also be 30. These form linear pairs, so this would be 150 and 150. So CAT is 150. BAT is 30. CAR is 30. And BAR is 150. Now that I look at what angles they were solving, we could have even done this without finding that 30-degree angle first. If we wanted to, these two are interior angles, and they'd be the remote interior angles of this exterior angle or this exterior angle. So those two added together should give us the 150, which they do. And then again, once we had the 150, we could have also got the 30. There are several different ways that you could solve this problem. All right, 24 and 25. Now, on this one, I think there's just a couple things left off on each one. A lot of people got the majority of the correct responses, but overall, the percentage was low. So, which are congruent? Base angles of an isosceles triangle are congruent. Corresponding angles of parallel lines are congruent. Diagonals of a rectangle are congruent. Diagonals of an isosceles trapezoid are congruent. Vertical angles are congruent. Linear pairs, those would be supplementary. So that's going to be checked off down here. Alternate interior angles of parallel lines, that's congruent. Opposite angles of a parallelogram, those are congruent. Consecutive angles of a parallelogram, so those are consecutive interior angles, or you could call them same side interior angles. Those are also supplementary, so that one gets checked off down here. So essentially, for congruency, everything except for F and I got checked off. On 25, only F and I got checked off. On 26, consider the following statement. For two real numbers, A and B, if A is less than B, then A squared is less than B squared. So, select all that can be used to prove that the statement is sometimes false. All we need on here is a counterexample, and in order for it to be a good counterexample, it has to work in the if statement, but be wrong for the false statement. And if you think about what this is, A has to be less than B. In order for this part to be true, A would have to be a negative number, and its absolute value would have to be greater than that of B in order for this to work out. So the only ones where it's actually going to work out is A and C. Now, you could go through each one if you want to, but those would be the only two counterexamples. And again, if you plugged it in, that's a true statement for that. But if you plugged in here, the A squared, so negative 4 squared is 16. 3 squared is 9. 16 is less than 9. That's a false statement, so A is a counterexample. Again, you're looking for something to prove that the then part is false. It has to fit the if, but the then part has to be false. On 27, fill out the reasons for the algebraic proof. I fixed this on the online submission form because there is one part on here that I didn't have the correct answer for. I was going off the county's answer key, and they didn't have it as one of the things on their answer key. But the first statement is what's given. Then, for this statement, well, we got rid of the 4. How did we get rid of the 4? We added it. So that's addition, property of equality. Then, from here to here, we actually distribute the 5. So that's distributive property. And that's the one that I left off originally because it didn't have it on the answer key. From here to there, we got rid of the 10. How did we get rid of the 10? We subtracted it. So, subtraction, property of equality. And then finally, to get rid of the 5, we divided it off. So, division, property of equality. Alright, so again, given, addition, property of equality, distributive property, subtraction, property of equality, division, property of equality. Alright, going on down to 28, which is the converse of the statement. If the triangle has all acute angles, then it is an acute triangle. Again, converse switches the if and then. So on this one, you guys did really good. So just looking through these, the fact that we have acute angles has to come second. The fact that it's an acute triangle comes first. So this one would not be it. This one, let's see, acute triangle, acute angles, looks like it's B. These added the word not. You don't do that for a converse. That would be an inverse where you add not to both the if and then, so you negate both the if and then. Or a contrapositive does a negation and switches. So, just to recap here, this one is the converse, which is what we're looking for. The first one is written in the exact same order. So this is the original conditional statement. For C, it kept it in the original order but negated, so that would be an inverse. And the last one, negated and switched, so that would be a contrapositive. And just to recap, if you had all those things as true statements, that's where we talk about it being a biconditional. All right, moving on. Number 29. This was a very low correct percentage. So, name the corresponding congruent parts of the following triangle. So, On this one, I believe what I did online was just asked whether or not you wanted me to go over it. So 75% of people basically wanted me to go over this. So on here, we have the triangles. It has some angle measures. We need to find the other angle measures to make sure that these, first of all, are the correct measures. But if we subtract these from 180, we do get 77, and we do get 41. So now, we just have to make sure we name the corresponding parts. So angle A would correspond to angle X. Angle B would correspond with angle Y. Angle C would correspond with, there was a missing letter there. That was Z. That got cut off somehow. Maybe that's why this was so missed. Oh, I think I did make this into multiple choice. So maybe it was missed because Z, for some reason, didn't get copied. So X, Y, and Z. All right, so then we have AC would correspond with XZ. AB would correspond with XY. And BC corresponds with YZ. And that's it. There used to be a Z there. Don't know what happened to it. All right, on 30. What is the value of Y? So all three of the angles have to add up to 180. 180 equals, add them all up, save some time. I just add them up here. So all the Y values, 3Y, 2Y, 2Y. That's a total of 7Y. 40, 40, and negative 5. That'd be 75. So we can first subtract off the 75. Leave us with 105 equals 7Y. And then 105 divided by 7 is going to give us 15. And that is Y. On 30. This is an exterior angle. These are the two remote interior angles to that exterior angle. Because again, it's not the one that's touching it. These two are the ones that are far away from it. So remote interior angles. The sum of the two remote interior angles to any exterior angle is equal to it. So this should be 7A plus 50 is equal to, add these two together. So I have 2A and negative 3A for a total of negative 1A. 80 and 70 would add up to 150. So then if I bring this over this way, I'd be adding one more A, so that'd be 8A. Subtract the 50, that'd give me 100. So then I'd have 100 divided by 8, which gives me 12.5. And we wanted not A, but what is the value of TRI? So TRI. So we got to plug it back in for that angle. So 70 minus 3 times 12.5. So 70 minus, if I do 12 times 3, so 12.5 times 3, that's 37.5. And if I subtract that answer from 70, we get 32.5. And that would be our final angle measure for this angle. All right, 32. Given R is congruent to T, so mark the figure. And R, angle RSU is congruent to TUS. We know that these two triangles are congruent by, well, we only have two pieces marked, but we also know this one in the middle is being shared because of the reflexive property. It's the same piece. So we have two angles and a non-included side. So two angles and non-included side would be C, AAS. Yeah, it wouldn't be ASA because the included side of those two angles is RS. We don't know that those two are congruent to start. All right, 33. If AB bisects CBD. So again, I'm going to draw on this figure. So AB bisects CBD. And CB is congruent to DB. then we can prove that these two triangles are congruent by what theorem or postulate? So we have this side, we have an angle, they have this shared side through reflexive property. So you have two sides and the included angle, so that would be side, angle, side. Two sides and the included angle. All right, going on to 34. On 34, if triangle RUS is congruent to triangle TSU, again, they did not draw a diagram. If you want to draw a diagram, you could. Then which is not true. So we just have to make sure that these are set up in corresponding order. If they're not in corresponding order, then it's not true. So RS and TU, they're in the same corresponding positions, so that's good. So then B, SUR, SUR, so that is backwards. TSU, that was forwards. That's not true. Ooh, I lied. That one's good. See, that one was tricky because they didn't go in corresponding order, but we have the same vertex, the same corresponding vertex there. So they're talking about the correct corresponding angles. Because if we were to draw this out, let me draw it real fast. R, U, and S, T, S, and U. Now I know I drew it as two separate triangles. You could have drawn it as the same, as two triangles that were touching. But just for purposes of this, so RS and TU, SUR, UST. See, they're in the same position. They are congruent. RU, TS. Those are also congruent. USR, USR, UST, UST. So that's this angle. So one was this angle, one is this angle. These two do not match up. So D is the one that's incorrect because they did not match up corresponding angles. So that one was tricky because the vertex of B was corresponding. So they were talking about the correct corresponding angles, even though the other two letters didn't go in corresponding order. On 35, given angle R is congruent to angle T, and angle RSU is congruent to TUS, then RUS is congruent to, so they're trying to match up a triangle, RUS. So one, I'm going to go ahead and put 3 here, 3 here. So 1, 3, 2, 1, 3, 2. So TSU. TSU. There it is. C. Right. So I used my congruency marks to help me that time. I did, and again, I used the order in which I marked them and did the same order on the other one. On 36, a mobile maker wants to place a weight at the center of gravity of a triangle piece of metal. Which does she need? Well, the center of gravity is the centroid. There's no actual math to that. You just have, that's definition. You have to know that the centroid is the center of gravity. On 37, F, B, and D are midpoints of these sides. So this is a centroid that we're dealing with. Again, centroid is where all the medians meet. So what's G called? G is, oops, G. It is a centroid, so that's a C now. Centroid. True or false? G is the center of gravity of the triangle. Yes, that's what the centroid is. It is the center of gravity. For these, you have to use the other property of a centroid. It's actually the centroid theorem. The centroid is 2/3 the distance from the vertex along the median to the opposite midpoint. So, if AG is 10. It's 2/3 of the overall line. This little piece is half of that one. So this is 5. Again, the whole thing is 15. So this is 2/3, this is 1/3. So this is 5, the piece they're asking for. DG. DG is 18. Then DC, well, they want the whole thing. Well, if this is 18, you got to double it to get this piece. So that's 36. And then 36 plus 18 is 54 for the whole thing. And then we have $21 for EB, which is the whole thing. Again, this is 2/3, this is 1/3. So if I take the 21 and divide by 3, this piece should be 7. And then this is double that, 14. And together, that's a total of 21. So GB, that's the piece I want here, is 7. All right, 38. If Q is the midpoint of MK, so Q is the midpoint of MK, and angle J is congruent to angle L, then the triangles are congruent by, now, you could make an argument for a couple different scenarios here. What I would look at is, I would say, hey, we have vertical angles. So if we went off of vertical angles, we have 2 angles and a non-included side, which is C. Now, I would also reason to argue, actually no, it would be the same property, because I would also be able to say that if we didn't prove that that one was congruent, we could have said, well, if this is congruent to that one, these are parallel, therefore M and K would have to be congruent. So if we didn't prove the middle one, then we'd have this one, and we'd still have angle, angle, side. So, should be C. On 39, draw the lines of symmetry for each of the concave figures. Now, I asked you online to input how many. Most of these were good. This plus sign was horrible, and the sun on the bottom was horrible. So, we'll spend more time on those. But for the first one, there's just one. You can only split it that way. This one, now if you look at this carefully, this side is much longer than this side. So we can split it here. We can split it here. But we cannot split it diagonally because, again, this length is much longer than this length. They're not congruent. So if you did it over this line, they would not match up because this piece would be trying to lay on that one, and this is longer than that one. So it doesn't work. If you need to, turn it sideways, and you can see it is kind of, this is lower than that. It does not match up exactly. So there's only 2 lines of symmetry here. On the cancel sign, you could go that way, or you could go this way. So there are 2. For the sun, you can go through each one of the points of the triangles. So 1, 2, 3, 4. And then you could also go between the triangles. 5, 6, 7, and 8. Now I had somebody put 42 on this one. I had some other really high crazy numbers. I don't know where those numbers came from, but there are only 8 that work there. Now, I did have some people put 16, which means you probably counted these lines twice. The smiley face, there's only 1. Oh, I'm sorry, you could not see that. Didn't move it up high enough. So let me go back over that. This one, cancel sign, again, only the 2. For this one, you could go through each of the triangles or between each of the triangles. So again, total of 8, smiley face, just the 1 straight down the middle. All right, on 41. In the diagram below, RAP is congruent to ISD. which point below can be the replacement of point S. So there's actually two acceptable places to put S. So let's see. From here, we went over 1, 2, 3, and up 1, 2, 3, 4, 5, 6. So 3 and then 6. So from here, I'm going to go 3 over, 1, 2, 3, up 6, 1, 2, 3, 4, 5, 6, which is up at 8. So this is at 3, 8. Or I could go over and down. So 1, 2, 3, and then down 8. Sorry, down 6, I mean. Down 6. I guess to negative 4. So I could also have a point at 3, negative 4. Now, only one of these 2 points is actually listed here, but I just want to show you could make this triangle either direction, and it's congruent either way. But again, only one correct answer is shown, so that's the only one that we're going to circle. Number 42. The rhombus below has vertex coordinates shown. Find the coordinates of vertex S. So, for S, if this is a rhombus, we should be able to just look at the difference from this side and do the same thing here. So from here, we went over 3 and up 4. So if I go from this point over 3 and up 4, we end up at negative 1, positive 3. And that's it. That's our answer. So again, I just follow that same pattern. Over 3, up 4. Over 3, up 4. On 43, we have a heart. That heart has been changed somehow. Which one is it? Well, this is a rotation. They rotated the heart around that point. It was the other way. There is also one other possibility, and I could say that you could have a reflection. The way you could have a reflection is if you drew a line somewhere in here, and you could actually reflect it. So there are 2. Now, on the test, again, it'll be clear as to which one it should be. There should only be one acceptable answer, unless it's a choice where it's like select more than one. And that could happen on the test. On 4. This, again, same thing. This could be a rotation around this point. Or it could be a reflection over the x-axis. So either one of those is acceptable. On number 45, translate the triangle plus 4 for the x, minus 2 for the y. So we go 1, 2, 3, 4, down 2. 1, 2, 3, 4, down 2. 1, 2, 3, 4, down 2. And that would be our new image. So with each point, we went over 4, down 2. Given this, find the coordinates of this after reflected over the y-axis. So again, we're reflecting over the y-axis. So the only thing that should happen from there is our x value should change to the opposite sign. So let me put this point. This is at negative 1, negative 2. So the x value should now be positive 1, negative 2. On here, this is at positive 1, 2. So its point should now be at negative 1, 2. Again, just the x value is changing signs. And then for n, this is at positive 4, 0. So it's now at negative 4, 0. Again, if you wanted to actually map this out, It have points here, here, and here. L prime, M prime, N prime. I cut that last one off. So, that's it. I'll redo 46 in the next video as well.